Push that rock here with Simpson Math. Let's talk exponent rules. So what we want to be able to do at the end of this video is simplify a monomial like this one that has a lot of exponents in the expression. But to do that, I want to make sense of the rules first. So let's think about an expression like this where we have 3 to the 4 over 3 squared. Well, we know that's 3 times 3 times 3 times 3 over 3 squared is 3 times 3. 3 to the 4th is 4 3's multiplied together, and 3 squared is 2 3's multiplied together. Well, we see that this gives us 9 times 9 over 9, which is 81 divided by 9, which is 9, because these 9's reduce. In other words, we could have backed up over here and we could have said, well, this 3 cancels and this 3 cancels, or maybe the reduce is the right word, and we have 3 times 3, which is 9. And that leads us to the idea that, oh, there's 2 down here, there's 4 up there, we're just taking 2 away from the 4, so why not just call it 3 to the 4 minus 2, which gives us 3 squared, which of course is 9. And that is the exponent rule. If you have x to the r over x to the s, then the rule says it's x to the r minus s. And it just makes perfect sense. Now, or at least for whole number exponents, as I've illustrated here, but it makes sense all the time. It works with all exponents. Now, what if you had 3 to the 4 divided by 3 to the 4? Well, that's a number divided by itself. Of course, that's 1. We know that's 1. Right? But if we use the rule, it's 3 to this 4 minus this 4, which gives me 3 to the 0. So we define 3 to the 0 to be 1. And in fact, we say any number other than 0 that's raised to the 0 power is 1. So the rule is x to the 0 equals 1 if x does not equal 0. And the reason why x can't be 0 is it's coming from this expression, and if I had 0 to the 4, that would not be defined if it was in the denominator. Now, what if we put it upside down, where we have 3 times 3 over 3 times 3 times 3 times 3, where clearly now we're taking 2 from the top away from 4 in the bottom. That's going to leave us 3 goes into 3 one time, 3 goes into 3 one time 1 is 1, over, these are gone because 1 times 1 is 1, times 3 is 9. So the rule now can be stated 2 ways. We can use the old rule, which is this 2 minus that 4, which that would be 3 to the negative 2. And so it shows us that this negative comes from a place where the base appeared more times in the denominator than it did in the numerator. So the negative means flip this, make it 1/3 squared, so you have 1/3 times 1/3, which gives you the 1/9. That's one way to express it. Another way to express it is if you have 3 to the 2 over 3 to the 4, is you could do, like we said, we took away 2 on the top away from the 4 on the bottom, so you can change it to 1 over 3 to the 4 minus 2, so that gives us 1 over 3 to the 2, which is the 1/9. So the rule, what's the rule? The rule is, if you have x to the r over x to the s, we already said it could be x to the r minus s, but it can also be 1 over x to the s minus r. And if you have x to the negative r, then that's 1 over x raised to the r, or it's 1 over x to the r. So notice the negative just puts the base in the denominator. Likewise, if I had 1 over x to the negative r, well, then that would be just x to the r. So if the base is a fraction, it will come back and be a whole number. Well, in this case, x could be a fraction, so we still have a fraction here, but you get what I'm trying to say, hopefully. Now, I think there's one more rule I need to talk about. What if we had, oops, what's going on here? What if I had 3 to the, whoops. Can we see that? Yeah, we can see that. 3 to the 2 raised to the 4. Well, that means that I have 3 times 3 to the 4, which means I have 3 times 3, but I have 4 of them. ever see this? Yes. Well, notice I have 4 groups of 2. So that's the same thing as 3 to the 4 times 2, which is 3 to the 8. Yeah, that's 2, 4, 6, 8 3s multiplied together, so it's 3 to the 8. So the rule here is x to the r raised to the s is x to the r times s. Okay, I've said a lot really fast. Let's lasso this up and try to summarize it. What I was trying to do there was make some sense with some simple illustrative examples of these basic rules. The rules are, if you have some base raised to the r over that same base to the s, that's the base raised to the r minus s. Or it's also equal to 1 over the base to the s minus r. If you have the base raised to the r raised to the s, that's the base to the r times s. You have the base raised to the negative r, then that's 1 over the base raised to the r, or 1 over b to the r. Likewise, if I have 1 over b raised to the negative r, that is just b to the r. And if I have b to the 0, then that is equal to 1, provided that b does not equal 0. So hopefully did I list all the rules? Okay, now we're going to use these rules to simplify this expression over here. Let's blow it up and get a better look at it. So there it is. Maybe we should have blown up the rules. For those of you, I don't know why it keeps doing this. There we go. I give everybody a chance to screenshot these rules here. Can we see them all? The bottom one's a little, okay. There they are. Okay, now let's use them to simplify a problem or an expression like this one. So, first thing I notice is that all of these are raised to the 3rd. So I can use the fact that raising a base to an exponent to another exponent, you multiply the exponents. So this is x to the 2 times 3, y to the 5 times 3, over x to the negative 4 times 3. That gives me x to the 6, y to the 15, over x to the negative 12. Then I can do the subtraction rule here. X to the 6 minus a negative 12, you got to be careful, that's a negative 12, and it's still being multiplied by y to the 15. But 6 minus a negative is 6 plus. I'm just putting that to emphasize that it's multiplication. But 6 plus 12 is 18. So this simplifies to x to the 18, y to the 15. And so the original expression that we had, which was x squared y to the 5 over x to the negative 4, all raised to the 3, simply simplifies to x to the 18, y to the 15. Math made simple, Simpson math.